is actually rub their feet on the floor and shock somebody? You guys? Everybody? Just about everybody. Yeah, it's fun. We're going to do that today. We're going to do that with a lot more power. Point where people's hair stand up because it's obviously called a hair-raising experience. Yes. Cool. We're going to do that with more power. And we're going to make some sparks. We're going to make some lightning and stuff like that. It's really cool. You guys mess with magnets before, right? That's a really important part of this. Mess with magnets. You guys like put like the plus sign and the minus sign together. When you guys put the plus and the minus together, did it go? Did they only go together, or did they push apart? What's that? You wanted to go together? Was it okay? Was it the plus or the minus, or was it plus plus, or was it like plus and minus together? Okay, plus plus. Well, that's close. When you have the same charge together, like a plus and a minus and a minus together, that's actually like they'll actually want to repel each other. Like when you have a plus and a minus together, they'll actually go apart. That just has a lot to do with what we're going with today, because everything that we're going to deal with today just about has to deal with the same. It has to deal with stuff that has the same charge, basically. Like for example, if we take for example something that has the same charge all at once, and we put a whole lot of power into it, and see what happens here. For example, like those magnets. We take something like that and put a whole bunch of power into it all at once. It'll repel to the point where it'll completely fly away. This right here is called a Van de Graaff generator. It's invented by a guy named Van de Graaff. Amazing. You guys invent stuff, you can name it after yourself. The me was taken a long time ago, but unfortunately, you guys can name it after yourself though. You guys hear that popping sound? It's sort of like popcorn, but not quite. This is a lot of static electricity being built up, a lot more than just a little bit of rubbing your feet on the ground. This is a lot of static electricity around here. Like if you can see, you probably can't see, but it's pulling my arm here and all this stuff right here. But it has nowhere to go. It wants to get to the ground, but it has nowhere to go right now. And we'll get back to that in a little bit. But right now, we need a volunteer real fast. Someone shoots up first, right there. Good. Alright. Alright, what's your name, sir? Joe, okay. What I need you to do is stand up here real quick, Joe. Stand up on top of that thing there. And if you could like loosen up your hair real good. Okay. Can you see yourself in the mirror? Very good. Okay, so what I need you to do is put both hands on here, and whatever you do, I'm going to go, okay? What we're going to do, we're going to fill you up with the same amount of electricity. It's the same charge. It's the same, like, just think plus plus together. Okay, so we're going to fill you up with the same charge and see what happens here. Obviously, you can't fly away. And your hair can't fly away. We're filling it with power here. Everything wants to get away. What's happening to his hair? It all wants to take off, but it's attached to his head. It can't fly away. But all this energy wants to repel. It wants to get away. But the easiest way to do that right now is to just, it's all over. Like it hairs on his arm, hairs on his legs, everywhere. It wants to take off. It wants to get away and repel away from the rest of electricity. The easiest way to do that is to just grab a piece of hair and just take off. But since it's attached to his head, it can't get away. So now if you feel all that tingling sensation and stuff, you don't like feel like you're gonna die or anything, right? Yeah, it's just a little bit of static electricity. Like if you were to like walk up and like, touch somebody right now, that would give them a big shock, really big shock, like way more than the rough stuff. But we're gonna get you down safely. Don't worry. But here's how you get down. Now I'm turning off the machine, but check it out. He still has a charge. His hair is still standing up. Right now the electricity wants to get to the ground, but it can't. Now when he touched the ground, as soon as he did, notice most of his hair. What happened to most of his hair? Most of his hair went down. Went boom. All the electricity inside him went to the ground. Everybody give Joe a hand. You have a seat. If you guys take away nothing else from this little class, demo, whatever, just remember electricity is lazy and wants to find the easiest way to the ground as possible. Now, you take us and you divide us up into 4 parts. 3 of those parts would be water. So that means electricity can go through us really easily. Now, remember that snap pop thing you guys were hearing? Now, I'm going to turn this back on. Make some more static electricity that doesn't have a route to get to the ground right now. So it just kind of, and all that snapping and popping has to deal with the fact that it's bouncing off the air. It's just kind of reacting to all the moisture in the air right now. Now, it wants to find an easy way to the ground, and if I give it an easy route, and this is why I'm kind of giving like safety measures of how to not get shot. If I were to just go ahead and walk and touch this thing right now, you guys hear that? Maybe see it? Or maybe if I were to walk up and use my whole arm, maybe see a little spark there. basically what I'm doing is I'm giving all this energy a shortcut to get to the ground. And it's going to do it, it's going to take that shortcut at the speed of light. Now we can do it with my body, or we can do it with something a lot cooler. Like this doohickey here. Pretty cool. This is called the grounding rod. This takes all that energy that's built up, sends it through here, through the rod, all the way through this wire, and into the ground, which is attached to the Van de Graaff at the speed of light. It does it all right away. And since this generator is still building up more and more electricity, if I were to turn this off right now, boom. Okay, and then it's all gone. Nothing left. Nothing left. So if I were to keep generating more electricity though, I'll keep doing it over and over and over and over. Kind of like in a thunderstorm. It'll keep doing it until all the energy is spent, and then it's all gone, and then the storm is over. Kind of like in light. Alright, so that being said, I need another volunteer real fast. Alright, it was kind of a tie. Let's do a tiebreaker. Another volunteer real fast. Okay, you do tiebreaker. Sorry. Alright, what's your name, boss? Ben, you stand up here real quick. You're going to do two things for me, okay? This isn't magic, this is science. The only difference between insanity and science is just a couple letters. Alright. You can stand if you want to, it's up to you. Now if you could hold out your left hand, that, and just open up your hand for me. You're going to put these in here. These are packing peanuts and styrofoam. If you can just close up your hand like that and just hold it out for everybody like that. Put your other hand right here. And whatever you do, don't let go of this little ball from you, okay? We're going to power you up like Goku, charge you up. First thing's going to happen is hair. Going to start percolating up a little bit by a little bit. I can never predict it right. This is also where you can see where you are or missed a few hairs. You can see that actually the sides are going up first. Usually we'll say like the bangs will go up first and then the back goes up first. I never get it right. So all the side hairs are going up first on Ben here. So then if you look at your other hand and slowly open your hand. Pretty cool, huh? All this, the same thing with those pie tins. All this electricity is building up in Ben, and since the peanuts are connected to Ben, the peanuts are also getting charged. So let's go ahead and pull both hands off and just hop down real quick. Good job, Ben. Everybody give Ben a round of applause. The thing with the peanuts is that they were charged as well. They wanted to repel. They weren't attached to anything, so they just said, sayonara, I'm out of here as soon as they had a way to actually get away, and actually get away from the other charges, the other magnets, I guess you can call it. So basically, that's static electricity in a nutshell. And with that being said,